Number 8 HMWPE wire is a Type 8 high molecular weight polyethylene insulated wire. It is a high-performance wire often used in demanding applications. Some of the key features of number 8 HMWPE wire include high tensile strength. HMWPE wire has a very high tensile strength, which makes it resistant to breaking and stretching. This makes it a good choice for use in applications where the wire will be subjected to a lot of stress. Another feature is a low coefficient of friction. HMWPE wire has a low coefficient of friction, which makes it easy to pull through conduits and other tight spaces. This makes it a good choice for use in applications where the wire will be installed in a confined space. Furthermore, it has excellent electrical properties. HMWPE wire has excellent electrical properties, including high insulation resistance and low capacitance. This makes it a good choice for use in applications where the wire will be used to transmit electrical signals. HMWPE wire is also resistant to chemicals and ultraviolet radiation, which makes it suitable for use in outdoor applications. Number 8 HMWPE wire is a versatile wire that can be used in a wide variety of applications. It is a good choice for use in demanding applications where the wire will be subjected to high stress or exposure to chemicals or ultraviolet radiation. Considering the high tensile strength, this characteristic is critical in situations where the wire is subjected to mechanical stress, such as in overhead power lines or in applications where the wire may be pulled or stretched. The high tensile strength ensures the wire can withstand these forces without breaking or significantly deforming, contributing to the reliability and safety of the electrical system. Regarding the low coefficient of friction, this property is particularly beneficial during installation. When pulling wires through conduits, especially in long or complex runs, a low coefficient of friction reduces the amount of force required to pull the wire. This not only makes the installation process easier, but also reduces the risk of damaging the wire's insulation, which could lead to electrical faults or failures. The excellent electrical properties of HMWPE wire are essential for maintaining signal integrity and preventing electrical leakage. High insulation resistance minimizes the flow of current through the insulation material, ensuring that the electrical current remains within the conductor. Low capacitance, on the other hand, reduces the amount of electrical energy stored in the insulation, which can affect the speed and quality of signal transmission, particularly in high-frequency applications. Chemical resistance is an important consideration in environments where the wire may be exposed to corrosive substances, such as in industrial settings or near chemical processing plants. HMWPE wire's resistance to chemicals prevents the insulation from degrading, which could compromise its electrical properties and lead to failures. Similarly, ultraviolet radiation resistance is crucial for outdoor applications where the wire is exposed to sunlight. Ultraviolet radiation can cause the insulation to become brittle and crack over time, which can also lead to electrical failures. The ultraviolet resistance of HMWPE wire ensures that it can withstand prolonged exposure to sunlight without significant degradation. The versatility of number 8 HMWPE wire makes it suitable for a wide range of applications, including power distribution, control circuits, and signal transmission. Its ability to withstand high stress, exposure to chemicals, and ultraviolet radiation makes it a reliable choice for demanding environments where other types of wire may not be suitable. When selecting wire for a specific application, it is important to consider the environmental conditions, the electrical requirements, and the mechanical stresses that the wire will be subjected to. Number 8 HMWPE wire is a good option for applications where high performance and durability are required. The specific gauge of number 8 refers to the American Wire Gauge, or AWG, standard. The AWG system is a standardized wire gauge system used predominantly in North America for the diameters of round, solid, non-ferrous, electrically conducting wire. The larger the gauge number, the smaller the wire diameter. Therefore, a number 8 wire is smaller in diameter than a number 6 wire, but larger than a number 10 wire. The diameter of number 8 AWG wire is approximately 0.1285 inches, or 3.264 millimeters. This diameter is important because it determines the wire's current carrying capacity, which is the maximum amount of electrical current the wire can safely handle without overheating. The current carrying capacity of number 8 HMWPE wire depends on several factors, including the insulation type, the ambient temperature, and the installation method. However, as a general guideline, number 8 copper wire with HMWPE insulation can typically handle around 40 to 55 amps in free air and 30 to 40 amps when installed in conduit or cable. It is crucial to consult the National Electrical Code, or NEC, and local electrical codes to determine the appropriate current carrying capacity for a specific application. The NEC provides detailed tables and guidelines for selecting the correct wire size based on the expected load and the installation conditions. Exceeding the current carrying capacity of a wire can lead to overheating, which can damage the insulation, cause electrical fires, and pose a safety hazard. In addition to its current carrying capacity, the voltage rating of number 8 HMWPE wire is also an important consideration. The voltage rating indicates the maximum voltage that the wire can safely withstand without insulation breakdown. HMWPE insulation typically has a high dielectric strength, which means it can withstand high voltages without failing. The voltage rating of number 8 HMWPE wire is typically 600 volts, which makes it suitable for most residential and commercial applications. However, it is important to verify the voltage rating of the specific wire being used to ensure that it meets the requirements of the application. The installation of number 8 HMWPE wire should be performed by a qualified electrician in accordance with the NEC and local electrical codes. Proper installation practices are essential to ensure the safety and reliability of the electrical system. This includes using the correct connectors and terminations, properly supporting the wire, and protecting it from physical damage. When pulling number 8 HMWPE wire through conduit, it is important to use a wire lubricant to reduce friction and prevent damage to the insulation. The lubricant should be compatible with the HMWPE insulation and should not degrade its electrical properties. Additionally, the conduit should be properly sized to accommodate the number of wires being installed, and the wires should be pulled smoothly and evenly to avoid excessive stress. The HMWPE insulation used in number 8 wire is a thermoplastic material that offers several advantages over other types of insulation such as polyvinyl chloride or PVC. HMWPE has a higher tensile strength, better abrasion resistance, and superior electrical properties compared to PVC. It is also more resistant to chemicals and ultraviolet radiation, making it a better choice for demanding environments. However, HMWPE is typically more expensive than PVC, which may be a factor in some applications. When comparing number 8 HMWPE wire to other types of wire, such as THHN or XHHW, it is important to consider the specific requirements of the application. THHN, which stands for thermoplastic high heat resistant nylon coated, is a common type of building wire that is widely used in residential and commercial wiring. It has a PVC insulation with a nylon jacket which provides good abrasion resistance and allows it to be used in dry or damp locations. XHHW, which stands for cross-linked polyethylene high heat resistant water resistant, is another type of building wire that is commonly used in power distribution and control circuits. It has a cross-linked polyethylene insulation which provides excellent electrical properties and resistance to moisture and chemicals. Number 8 HMWPE wire may be a better choice than THHN or XHHW in applications where high tensile strength, low friction, or superior resistance to chemicals or ultraviolet radiation is required. However, THHN and XHHW may be more cost-effective in other applications where these properties are not as critical. In addition to its use in building wiring, number 8 HMWPE wire is also commonly used in various other applications such as in automotive wiring, marine wiring, and industrial equipment. Its high performance and durability make it a reliable choice for these demanding applications. When selecting number 8 HMWPE wire for a specific application, it is important to consider the following factors: the current carrying capacity required for the application, the voltage rating required for the application, the environmental conditions that the wire will be exposed to, the mechanical stresses that the wire will be subjected to, and the applicable electrical codes and standards. By carefully considering these factors, it is possible to select the appropriate type of number 8 HMWPE wire and ensure that it is installed correctly and safely. Furthermore, understanding the specific properties of HMWPE is crucial. High molecular weight polyethylene is a type of polyethylene with a high molecular weight, typically ranging from 200,000 to 500,000 grams per mole. This high molecular weight gives HMWPE several desirable properties, including high tensile strength, high impact strength, and excellent abrasion resistance. HMWPE is also chemically inert, meaning it does not readily react with other chemicals, and it has a low coefficient of friction. These properties make HMWPE a versatile material for a wide range of applications, including wire and cable insulation, plastic films, and industrial components. The manufacturing process of HMWPE involves polymerizing ethylene gas, which is a simple hydrocarbon molecule, under high pressure and temperature in the presence of a catalyst. The catalyst controls the polymerization process and determines the molecular weight and structure of the resulting polymer. The HMWPE resin is then extruded or molded into the desired shape, such as a wire insulation layer. The thickness of the HMWPE insulation layer on number 8 wire is typically around 0.45 inches or 1.14 millimeters. This thickness provides adequate insulation for voltages up to 600 volts and helps protect the wire from physical damage. The color of the HMWPE insulation can vary depending on the application. Common colors include black, white, red, and green. The color coding is used to identify the different wires in a circuit and to ensure that they are connected correctly. The weight of number 8 HMWPE wire is approximately 23 pounds per 1,000 feet. This weight can be a factor in applications where the wire needs to be supported or transported over long distances. It is important to use appropriate support structures and lifting equipment to handle the wire safely. When splicing number 8 HMWPE wire, it is important to use connectors that are specifically designed for HMWPE insulation. These connectors typically have a sharp, pointed design that allows them to penetrate the insulation and make a reliable electrical connection. It is also important to ensure that the connectors are properly tightened to prevent them from loosening over time. Regular inspection and maintenance of number 8 HMWPE wire is essential to ensure its continued performance and safety. This includes checking the insulation for cracks, abrasions, or other signs of damage. It also includes verifying that the connections are tight and that the wire is properly supported. If any damage is found, the wire should be repaired or replaced immediately. In summary, number 8 HMWPE wire is a high-performance wire that is well suited for demanding applications where high tensile strength, low friction, excellent electrical properties, and resistance to chemicals and ultraviolet radiation are required. It is important to select the appropriate type of number 8 HMWPE wire for the specific application and to install it correctly in accordance with the NEC and local electrical codes. Regular inspection and maintenance are also essential to ensure its continued performance and safety. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is widely adopted by state and local jurisdictions and is considered the authority on electrical safety. The NEC contains numerous articles and tables that are relevant to the selection and installation of number 8 HMWPE wire. For example, NEC Table 310.16 provides the allowable ampacities of insulated conductors rated up to 600 volts, including number 8 copper wire with various insulation types. This table is used to determine the appropriate current carrying capacity for a specific application based on the wire's insulation type, ambient temperature, and insulation method. NEC Article 310 covers the general requirements for conductors for general wiring. This article includes information on conductor identification, insulation requirements, and ampacity ratings. It also provides guidelines for directing conductor ampacities when multiple conductors are installed in a raceway or cable. NEC Article 392 covers cable trays. Cable trays are rigid structures that are used to support cables in industrial and commercial applications. This article includes requirements for the installation of cables in cable trays, including the spacing between cables and the support requirements. NEC Article 396 covers messenger-supported wiring. Messenger-supported wiring is a method of supporting cables using a messenger wire, which is a high-strength wire that is strung between supports. This article includes requirements for the installation of messenger-supported wiring, including the size and type of messenger wire required and the spacing between supports. NEC Article 400 covers flexible cords and cables. Flexible cords and cables are used for connecting portable appliances and equipment to a power source. This article includes requirements for the construction and use of flexible cords and cables, including the type of insulation required and the allowable ampacity. It is important to consult the latest edition of the NEC and any applicable local electrical codes before selecting and installing number 8 HMWPE wire. The NEC provides detailed guidelines and requirements for ensuring the safety and reliability of electrical systems. Ignoring these guidelines can lead to electrical hazards, property damage, and personal injury. In addition to the NEC, there are also other standards and organizations that provide guidance on the selection and installation of electrical wiring and equipment. For example, the Insulated Cable Engineers Association, or ICER, publishes standards for insulated wire and cable. These standards cover the construction, testing, and performance of various types of insulated wire and cable. The American National Standards Institute, or ANSI, is a non-profit organization that develops and publishes voluntary consensus standards for a wide range of products and services. ANSI standards are often referenced in the NEC and other codes and regulations. When selecting and installing number 8 HMWPE wire, it is important to consider all applicable standards and guidelines to ensure that the electrical system meets the highest standards of safety and performance.